All right, let me show you how to solve some of these problems here. So what we have is we need to determine the end behavior. We also need to determine the multiplicity and also the zeros of this function. So the first thing I always want to do for end behavior is determine what the degree is and determine what the leading coefficient is. So remember, we're going to use, by determining the degree and the leading coefficient, we're going to use the leading coefficient test. So the degree in this problem is 4, and the leading coefficient is 1. Remember, the leading coefficient is your coefficient of your leading term, which has your highest degree. So since I have a degree of 4, which is even, and I have a leading coefficient of 1, which is positive, by definition of the leading coefficient test, I am going to have end behavior that's going to rise to the left and rise to the right. So that's very important for me to understand. And I can give a good sketch here. Rises left, rises right. All right? I don't know what's going to happen in between, but I know it rises left, rises right. So now the next thing I need to do is find the intercepts, right? Remember, the intercepts are the same thing as the zeros, the roots, and the solutions. So to find the intercepts, f of x equals 0, right? Because it's where it crosses. So f of x is going to equal 0. So I set 0 equals f of x. Then I have x to the 4th minus x cubed minus 20 x squared. All right? So there's a lot of different ways we can solve this. We could look at solve by graphing. Obviously, take out a graph calculator and graph it, right? You could solve by completing the square, quadratic formula, or factoring. All depends on what form you have. Well, here, remember, quadratic, it has to be in the quadratic form. Now, there is a way we could do that. But first thing I always want to do, I want to look at factoring. You always want to see what can you factor out. Anytime you're going to be solving a problem, always try to see, how can you simplify this? I noticed that all of these share an x squared. So I can factor out an x squared term. So I'll be left with x squared minus x minus 20. So now, by the zero product property, I have x squared equals 0 and x squared minus x minus 20 equals 0. So here, we're looking pretty good, right? I got x squared equals 0. I know that. Here, I'm kind of running into some problems because I still have not solved for x. So here, at least it's a quadratic, so I could do factoring, completing the square, quadratic formula. Well, what you'll notice is if you want to factor this, you can see this actually isn't that bad to factor. X minus 5 times x minus 4 equals 0. Now I have to use the zero product property again. X minus 5 equals 0, and x minus 4 equals 0. So x equals 5, and x equals positive 4. All right, so here's where it gets interesting. I need to determine the multiplicity. And remember, the multiplicity is going to be kind of the exponent of your factor. So if I look at here, I could say, all right, well, here I have two factors here, because I could represent this as, I could rewrite that as x minus 4 and x minus 5, x minus 5 and x minus 4. How do I rewrite this kind of in a factor so it looks like x minus h? So what I can do is I can say x minus 0 squared equals 0, right? That's the same thing. And what you'll notice is now the exponent of my factor is 2. When you have an exponent with the factor of your factor of 2, that means your 0, which x equals 0, right? When you solve for x, it's going to have a multiplicity of 2. Now, these two factors only had an exponent of 1. So their zeros have a multiplicity of 1. So why does that matter? Why do we care? Well, we have the end behavior, right? Rises left, rises right. When you have an even multiplicity, your graph is going to touch at that 0. So my graph touches at 0. I don't know if it's going to touch open or touch back. When it has an odd multiplicity, it's going to cross through the 0. So my graph crosses at, that's wrong. That's positive. There we go. It crosses at 5, 1, 2, 3, 4, 5, and crosses at negative 4, 1, 2, 3, 4. All right? So to connect kind of my graph, if I was going to look at this multiplicity 2, that means it's going to touch. So it's going to either look like this or look like that. Well, if it looks downward, I can connect my graph to look something like that. So there it goes, ladies and gentlemen. That's a rough sketch, but hopefully with my algebra you can see how I determine the end behavior, factor to find the zeros, and determine the multiplicity. There you go. Thanks for watching. Any questions, comment below.